Hey everyone, how you doing today? Wazoo here, and this is a tutorial video in long form on putting together your own to-do task planner application. Yeah, you can see here in front of us, we've got a demo up and running of a to-do application that's structured in more of a Kanban type approach, if you're familiar with how one of those works, in that your items are divided into what's called lanes. And we've got 3 lanes in front of us called backlog, doing, and done. And I just stole this from basically tools like JIRA or Trello, things like that, where you can create different lanes for different things that you're working on or what you want to accomplish. And I figure since this is the first video of 2024, hello 2024, that you might want to consider using something like this to put together your own tasks or items that you want to tackle throughout this year. Yeah, and this will be using Java Spring Boot, if I didn't mention it earlier, and some Thymeleaf for the front end, along with some basic JQuery to get the requests moving from our HTML page to our backend. And so let's go through a quick demo here of what we'll be building, and then we'll get started. So as you can see, we've got 3 lanes here. Like I mentioned, a backlog, doing, and done. And you can see that each item is colored with a different color. Well, hopefully you can tell. In the backlog, I've chosen a blue color. In the doing column, I've chosen a yellow because it's kind of things are in progress. And then done, we've got a success color. So it's using the green borders to outline all the items. And we can add a new to-do item. So let's call this putting out on social media. And we'll hit add. And it'll be added automatically into our backlog list. So all new items will show up in our backlog. And the way we move them through the different lanes is we just give them a single click. So let's, for example, once we finish shooting this tutorial, we then click it and it'll show up in the done column. If we click on an item in done, it won't move. It'll stay where it is because there's nowhere for it to go. And if we click on an item in the backlog, it'll show up in the doing column. So yeah, this will be the app that we're putting together today. This is more of a beginner/intermediate kind of application. I really urge you to keep an eye on the timestamps, the chapter select things down below in the video slider to go ahead into the section that you want to get more information on. I'll try and break it up into something that's logical. And yeah, let's just get to it. I think this will be a lot of fun. Welcome to 2024, everyone. First things first, we're going to get on to start.spring.io to generate the project template for our Spring Boot application. So we're going to be choosing the Maven checkbox, Java, of course, Spring Boot 3.2.1, that this will be the latest release version that we're using. It may be different by the time you see this video, but we'll be using 3.2.1. And for a name, we'll just call this Spring Boot 3 to-do application. Okay, and we'll keep the packaging a jar file. And we'll be using Java 17 as the default. And then let's go ahead and add our dependencies. Okay, so we've got the Spring Boot Dev Tools, Lombok, Docker Compose support for our Docker scripts, Spring Web, Spring Data JPA, the MySQL driver, Thymeleaf, and finally validation. When you've configured everything here, just hit the generate button, download the zip file, and extract it to wherever you want on your hard drive. Okay, so we've downloaded the zip file, which contains a Java Spring Boot template project where we've opened it up in Visual Studio Code. And here we are with our basic project structure. You can see we've got a few files here in the root of the folder. We've got our compose.yaml file, and this is our basic Docker setup. We'll be deleting all of this, but we can leave this for now. We also have the 2 MV and W cross-platform scripts, which is used to help our Spring Boot server with executing and running. when we need to deploy it to production or run it on a container, anything like that. And the pom.xml file, which is our basic package dependencies that we're using in our application. So this is similar to the Ruby on Rails gem file or the package.json in any JavaScript project. And so we've got some basic dependencies here. We're going to add one more, which we will do right now. We want to be working with a .env environment file to inject some username and passwords for our database. So in order to do that, we want to add a .env file. So just hit new file in the root of our project, and we'll call it .env. And let's go ahead and put in a few values here, which I'm going to just cut and paste in. So we've got a database name. We're going to call it spring_data, a database user, spring_user, a database password, spring_password, and a database root password of spring_root. And I'll be showing you in a few moments where we're going to be setting that up. So back to our POM file. Notice in the section here, we've got a properties section with java.version. So we can create some other variables for dependencies that we want to bring in. So we are going to create a .env version, and it's going to be 4.0.0. And then we're also going to be creating a bootstrap version, bootstrap.version of 5.3.0. Bootstrap.version, closing that off. And then we're going to create one more for jQuery, jQuery.version 3.7.1, and then closing that off, jQuery.version. And we'll be making use of that right in the dependencies section here down below. We'll be adding 3 new dependencies to this project. Okay, make sure to click always on that dialog box to make sure that the project updates itself as you add new dependencies to this pom.xml file. Okay, so first things first, we're going to be adding the spring.env package from me.paulschwartz. This is on the Maven repository, and we've given it we're using the variable .env version, which of course we defined above here as 4.0.0. And then we're going to be loading in from org.webjars, the bootstrap, and jQuery jars. We'll be making use of those from our HTML file. So that's all we need to add to our pom.xml. By default, it should either prompt you, VS Code should either prompt you to reload those dependencies, or it will do so automatically if that's already set up. So let's just give ourselves a little bit more room here. Okay, so we've got our environment file set up. We've got our environment file set up with these different key values, and we've got our pom.xml file set up. And now we can jump to our docker compose.yaml file. So let's double click on the compose.yaml. Let's delete all this. And let's go through creating our own Docker compose file. So what we're going to put in this compose file is the images for our database and the database GUI tool, which will be called phpMyAdmin. Okay, so we need to declare at the top a version tag. We'll be using version 3.9. And then we're going to set up a services section. So we're going to have 2 services here. So one is our database. And then one is going to be our phpMyAdmin. Okay, and then we are going to define a volume section with DB data, and then we're going to finally define a network that all of these images can listen on within the Docker container. So I'm just calling it Spring Network. Okay, and then now let's go back and fill out each of these different services. So in our database, we're going to be using MySQL version 8.0. And for a restart option, we're going to use unless stopped. We're going to specify an environment file with env_file, and we'll give it the value of .env, which is our environment file. And then the environment variables we'll be using is MySQL database will be set to our database name. Our MySQL password, the value of that will be set to the database underscore password value from our .environment file. The MySQL root password value will be set to database root password from the .env file. And then finally, the MySQL underscore user will be set to our database user from the .env file. And then we're going to be adding a health check, and I'll show you where that health check comes in handy. So maybe we'll leave that section for right now. So we'll expose some ports on this. 3306 we're going to map that to the internal port 3306 in this image. And then we're going to specify our volumes. And we'll be using that DB data and giving it a path of var/lib/db. And then finally our networks. We're going to be using that spring-network. Okay, and then now onto the phpMyAdmin service. This service depends on the database coming up. So it depends on the database, and the condition is set to service healthy. So again, I'll go through the health check in just a minute here once we finish setting this up. So for an image, we're just going to be using phpMyAdmin/phpMyAdmin. For restart flag, we're going to be using unless-stopped. For our ports, we're going to define 80. We're going to expose 8081 to be mapped to the internal port of port 80 on this image. And again, the environment file is going to be set to the .env. And for some environment variables, we only have two, pma_host, and it's going to be set to our database. We need to specify the image, basically the host that we are tying this admin GUI tool to, and it is the host will be the database image. Localhost won't work because the only thing running on this image is phpMyAdmin. So in order to communicate with this other image that we've set up for our actual database, then we need to reference it by the image name of database. So set that to database. And then for a MySQL_root_password, we want to read that from the environment, the .env file as database_root_password. And then for our networks, we're going to be using the spring-network. So when I talked about the health check, let's go back up to the database. So sometimes when Docker loads up our images and gets them up and running in order for application to access them, things need to happen in specific order. So even though we have a depends on flag within phpMyAdmin, it's not enough to just depend on the database. Like you'll find that in most configurations that you'll declare a depends on as the actual other image that you're using. Okay, so even though a Docker image has a depends on flag, which depends on another image being in what's called a healthy state before this one is started up. The problem is, or one issue, not the problem, one challenge is that sometimes the image then proceeds to do some startup tasks of its own, which could take a few seconds to a few minutes to get up and running. So for example, this database, as it's starting up, even though it would report as healthy to the phpMyAdmin, it hasn't yet added a default user account, which is what's happening with these environment variables. You'll see in the logs shortly that it will attempt to create this first user of database user using database password and then this database name. And so this takes a few seconds. And so what could happen is that while this is initializing itself and starting up and doing all of that preliminary work, phpMyAdmin could be trying to access it to do something else, or whatever this other image is could be accessing it to do something else. So in order to kind of wait for things to be ready, in order to then execute this next image, we can put in what I alluded to earlier, which was a health check. So let's create a health check here, and the test will be command MySQL admin, and we are going to ping -h localhost, which is itself, and then we're going to use -u to log in. We're going to ping with root, and then the password for this will be taken from the environment file again, but it's going to show up as -p, and then we need to use 2 $, and then database root password. Okay, so we've got the test written up, and then we need to add a timeout. So I'm going to put in 20 seconds, 20s, and then retries. Let's go with 5. All right, so we've got a health check set up. So now what I'm going to do is, using the Spring Boot dashboard extension, I'm going to try executing this. Make sure your Docker desktop application is all up and running, and then click on Start. And then it should go through the process of pulling down the images that we've defined in our compose file. Okay, so we can see here that the container, the database one, is in a waiting state. And so this is waiting for the health check ping to be successful, and then it will move on to jump-starting our Spring Boot application server. It's now registered as healthy, and it's now starting up our Spring Boot container, and it is now running on port 8080. And I'm not going to bother testing it. You can test it for yourself. It's going to be the default error page. And yeah, but we just wanted to make sure that everything was set up correctly in our environment. So let's go ahead and stop that. And let's go back to our application. Okay, so now what we're going to do is move on to creating our first model, our first and only model in this application. We're going to be following a MVC model pattern, which Spring Boot is really built around. And this, of course, stands for Model View Controller. This is a way of structuring your application into models, which contain our objects and their data, basically referencing their rows in the database, which are mapped to model objects in your application. And then we've got controllers, which is basically the glue between the models and the views. So it pulls in the data that it needs from the models, and then it does any kind of business logic or any other logic that you're looking to do, and then finally displays it through the view templates through Java Spring Boot or any other server that you're using. We want to be in the com/example/application name. Okay, so from this folder, let's create a few package names. So we're going to create a few new folders. So we're going to create one called config. Let's just do them all at once. We're going to create one called controllers. We're going to create one called models. We are going to create one called repositories. And we're going to create one called services. So we'll be going through and filling out files in each of these. So let's, like I said, let's start with our model. So in the model folder, let's create a new model called to-do. And it will be a class. Visual Studio Code should create a package declaration and default class thing for us. So what we're going to be making use of is Lombok to generate some helpful methods for our model file automatically. So we'll be using the @entity, the @allargs constructor, the @noargs constructor annotations, the @builder, we'll be making use of the builder pattern when we can, and finally the @getter and @setter. All of these are really helpful annotations for use in this object. So our first field we're going to define is our ID, and it will be using the @id annotation along with @generated value. And our strategy that we're going to define here is generation type auto. And it will be a long called ID. And then we're going to have a description for each to-do item, which is going to be a string. And then we're going to have a status. So we're going to use the @enumerated annotation, and then an enum type of string. And it will just be called status type status. Finally, a local date time field for the created @ and a local date time updated @ property. Okay, so hopefully this is all visible for you. Okay, and then under models, we're going to have to create another enum, which will be called status type. So status type.java, and then if we come here in Visual Studio Code, we can just select enum, and we just have 3 statuses. So we've got backlog, doing, and done. Those are the 3 that I came up with. Feel free to change this around, create your own, play with it. Just do whatever you want with this application. And you can see that we should have no more red underscore angry squigglies from VS Code with our defined fields in our to-do model. So now that we've got that created, let's create our repository. So the repository is an object that interfaces our model and the actual database. So within the repositories folder, let's create a new file, and we'll just call this to-do repository. And it will be an interface. And we are going to extend the list CRUD repository interface, making use of to-do and long. Okay, so long will be the key to index our to-do object within this interface. And now we want to create a to-do service, which we'll be using when we want to interface with our controllers. Usually in an application, instead of working with a repository directly, we should be going through something called a service, which is just basically another type of layer that will give you some flexibility to add a bit more smarts to how you're working with your data, which we'll be going through shortly. So in the services folder, let's create a new file, and we'll call it to-do service. And we'll be using the service annotation from Lombok and the allargs constructor annotation. And so we want, from within here, is we want to be accessing the to-do repository. Okay, so we want to create a getAll method to get all of the to-do items. So public list to-do getAll. And we will just return to-do repository find all. Okay, then we want to add a save method. So we'll create it as a public, and we'll call it save. And as a parameter, we'll accept another to-do. So if the new to-do has an ID value of null, it means we haven't saved it in the database yet. So let's set the created @ field to be local datetime right now. And then we want to also call new to-do set updated @ to be also local date time now. And then what we want to finally do is return to-do repository.save, and then this new entity, so new to-do. So we save this new to-do file, and then we get it back from the repository, and then we return it to the caller. Anytime we call save, passing in a to-do object, if this to-do object that we're working with has a null ID, it means it hasn't been persisted to the database yet, and then therefore we set a created at date timestamp of right now. Otherwise, or for everything else, for any other operation we want to do, we'll set the updated at value to be the local date time now. And then finally persist it in the database through the to-do repository and return it to the calling function. Okay, so we're almost ready to start a first test. And let's first define what I'm going to call a page controller. So in our controllers file folder, create a new file and just call it page controller. And it will be a class, and we are going to be using the @controller annotation and @required args constructor annotation. And then we're going to be pulling in the to-do service. And so when we show up here, when we show up to the application, we will be listening in on a get mapping. So when we hit the default URL of our application, it will execute this get mapping of the empty slash. And we're going to be returning what's called a model in view. So model in view equals new model and view. And the name of our template file is going to be called index, which we'll be creating shortly. And we are going to return model in view. Okay, so the name we've given this model in view is index. We're passing it in as the view name parameter. And so all we need to do is make sure in our resources / templates folder, we create a new file and call it index.html. So the name of the file here, so index, has to match the name that we're defining in this model and view constructor object. Okay, so now I'm going to paste some HTML and we're going to go through it. Okay, so first things first, we've got our doctype HTML declaration. We then have a namespace declaration of our thymeleaf.org, which is now tied to the th, which will demonstrate shortly how it's being used. And then we have some meta information here. So we're defining a char set of UTF-8, an XUA compatible flag to be IE equals edge. I don't know if you need it anymore in HTML5, but it's probably just a safe one to keep anyways. It doesn't hurt you by keeping it, but it's probably deprecated by now. And then we're declaring a viewport of width equals device width and initial scale equals 1. And then we're including the Bootstrap style sheet. So remember in our pom.xml, we've got our WebJar, our Bootstrap WebJar, which is version 5.3.0. So the th, which is our reference to the Thymeleaf metadata, href of the path to our Bootstrap CSS file, which is /webjars/bootstrap/ version number, which is 5.3.0, CSS bootstrap min.css. And then we have another declaration for a CSS file, which we'll create shortly. But for now, we'll leave it blank. It will be a file in our static folders. Okay, next we have a declaration within the body. At the end of the body, we've got a script declaration referencing the JQuery JavaScript file, the minified version, which is also part of the WebJars JQuery that we downloaded. And then back to the WebJars Bootstrap that we downloaded, we're referencing the bootstrap.min.js JavaScript. And we'll be shortly adding our own JavaScript file here. So let's go ahead and do that right now. So in the static folder, create a new file and we'll just call it app.js to match the app.js that we've declared here. So we're just going to use a little bit of ES6. And so we're going to have a dollar string for our jQuery reference. And then, so when everything is ready, I'm just going to display a console log message of jQuery ready. So hopefully you don't let the JavaScript arrow functions fool you. I just really enjoy putting everything into arrow functions. I think it looks a lot neater, but at any rate, this is the same as the old standard way of creating a jQuery ready function. Okay, oh yeah, and we also had a styles.css file that we were referencing from the top of the index.html file. So in the static folder, create a styles.css file. And we'll be adding some styles here shortly, but let's just make sure it's available right now. All right, now the one thing we have to do is create some properties, define some properties in our application.properties. This is a special file that ships with Spring Boot, which Spring Boot reads during startup of your server to give you a way of overriding default configurations for just about everything within the Spring Boot engine. So Spring Boot follows a pattern of convention over configuration. So it tries to follow a pattern of best practices for the defaults of everything that you're making use of in the Spring Boot server. And so defining anything in this application.properties file will override any of these defaults. So we're in the source/main/resources folder, application.properties. And so first what we're going to do is we're going to define a server.port of 8080. Okay, and then we're going to define a few more keys for our Spring JPA settings. So spring.jpa.hibernate.ddl auto equals update, and spring.jpa.show.sql equals true, and spring.jpa open in view equals false. And so basically what Spring Data will attempt to do, is during startup, it'll go through the models in your application, it'll look for any changes, and then it'll try and reconcile that with the state that your database is currently in. So if you're missing tables in the database that should be mapped to models that you have added to your application, then during startup, Spring Data will attempt to create the mapping between those new models and the new tables in the database. The show-SQL flag will give you the ability to see all of the SQL that's being executed through the Spring Data layer in the log file of your Spring Boot server. I just thought it's kind of a neat thing to go through while you're debugging. So we can leave that on as true. You can turn it off at your leisure. And then finally, we will define our Spring Data Source. So we've got our spring.datasource.url to be the MySQL localhost 3306 and database name, port 3306/database name, which we're pulling in from the .env file, remember? And then our driver class name is set to be the mysql.cj.jdbc.driver. And finally, our data source.username is equal to the database_user, and the password is our database_password, which of course is from our .env file that we declared earlier on. Okay, so I think we've got all those things set up. And one more thing before we start this up, we're going to create what's called seed data. And basically, this is a way of being able to add some default data into our database. That way, after we start it up, before we go through the steps of setting up a user interface, we can verify that objects and records are saving correctly to our database right away. So back in our config folder, let's create a new file. And we're going to call it seeddata.java. Okay, it'll be a class. And so we're going to give it the component annotation and the required args constructor annotation. we're going to be implementing the command line runner interface. And then finally, we're going to be referencing our to-do service. So finally, we've got, because we've implemented the command line runner interface, we have to declare an override for a method called run. And so this will get executed upon startup of the Spring Boot server. And all we're going to be doing here is we are going to be using the service, so the to-do service.getAll method, to return a list of all the to-dos in the database. If our list is empty, then let's go ahead and create 3 new records. So we're using the builder pattern. So to-do.builder, we're defining a description. We've got 3 different descriptions here. So edit tutorial, shoot tutorial, and then tutorial script. Those are the 3 that I came up with. And we're giving each of them a different status so that we can demonstrate that they're in the different lanes that I mentioned during the demo. So we've got a status type of backlog, a status type of doing, and a status type of done. And then finally, we're calling the build.build method, which will then package all this up into an object because of the builder annotation and return it into our to-do declaration here. And then we're just going to be saving them to the to-do service with the help of our save function. Okay, so I think we're ready to test it out. Let's go ahead and run it again. So if we haven't deleted the images, the Docker images that we pull down for the database and phpMyAdmin, then what's going to happen is it'll do a quick check to verify that those configurations are consistent with the existing images. If they are, then it will just move right along into starting up our server. And you saw right here during the beginning that we've started up our server. We've got our port listing on port 8080, and then we're going through our Spring Data layer to create these 3 new objects that we've defined in this seed data command line runner implementation. So let's go ahead. We won't see anything if we go to port 8080. Okay, we won't see anything, but you should see in the console, we've got a jQuery ready text, which is a good sign that things are running correctly on our page, are loading up correctly on our page. We've got jQuery and the Bootstrap CSS loading up. But let's look in the database. So if you create a new tab in your browser and go to HTTP localhost port 8081, you should get to the phpMyAdmin login page. And if you recall from the environment file, the username we're using is spring_user, and the password is spring_password. Okay, hit the login, and we've got 3 databases here, 3 database names within this database setup. But the one we care about here is the spring_data. So go ahead and click that. And we've got our 2 different tables set up, well, 1 table and 1 sequence. So we've got a to-do table, which is the database representation of our to-do model, and then a sequence, which is what's going to be used by Spring Data whenever we want to create a new to-do item. It's what's used for creating a ID for that model. Okay, so let's go into the actual data. So in our to-do table, we've got 3 records, which were persisted through Spring Data during the startup with the help of that seed data object that we just discussed. So we've got an ID, a different ID for each record. We've got created at timestamps. We've got the description set up. We've got a status. And then finally, we have our updated at timestamp flag. So all this looks correct. Everything looks really good. I'm pretty happy with this. So now we can just go back and add some HTML and Thymeleaf. So we can keep the server up and running, and it should reload itself as we update the HTML. Okay, so back in our index.html file, let's go ahead and insert some more HTML code. So I forgot to mention that, of course, the source code to this project is freely available. It's down below in the description. I've got a link to it, as well as I'm hoping to get this up as a actual product on Gumroad that you can download, which would be a great way to support this channel. So please consider picking that up. I'll make more references to it as I put it together. All right. So we've got let's just shrink that up so we can see more of this. So we've got a lot of HTML here. So let's go through this let's go through this where we can. All right. So we've got a basic nav bar, which we saw at the top, which just defines our application name. So To-Do Planner is what I've called this. And then we've got a navbar, what's called a navbar toggler, which is just used whenever the screen goes into a responsive, so a mobile view. We've got a small link to the current page. Since there is only the current page, I don't know why you would want to keep this. Maybe consider deleting it. I just thought that you might have like an about page or some other pages that you might want to put together in this application. So for now, I'll leave this, and it's just called home. And so if you click on it, it'll just go back. It won't really do anything. It'll go back to itself, in other words. And then we've got that inline form. Let's see, will it show? Okay, so it shows. Okay, so we've got maybe let's try and match up. So we've got a nav bar at the top, which has our To-Do Planner H1, so our To-Do Planner title. And then we've got our navbar toggler, which is our icon, which drops down a way to add a new to-do item. So right now the form does nothing, but you can add a new description here. Click the add button eventually. So we've got this, which will expand and shrinken with the help of this navbar toggler. And this section right here is defined here as this navbar collapse section. Whoops. Okay, and then as you saw, we've got an input form control that will eventually be our description for the new to-do item. So let's shrink that up. And then finally, we've got 3 within a container fluid class, which defines the whole body here. We've got 1 row set up and 3 different columns. So each column will be its own lane. So the first one is called backlog, the second one is called doing, and the third one is called done. So if we expand the screen, then it will expand those 3 columns. And if we shrink down the screen to a mobile view, it will then display this in a more mobile-friendly way. All right, so we've got these 3 sections set up. And now let's go ahead and keep adding things to it to make it match how we had things in the demo. So first of all, the way we add something is we go back to our form here. Thymeleaf recommends defining an action of just an empty hash. And then followed by a th action declaration. Basically the path where you want to submit this form to, and it will be at open squiggly bracket /todos/new. And then the object that we're going to be submitting, so th::object, is going to be a $, open squiggly, new to do, close squiggly. And then finally, the method we're going to use is post. Okay, so how do we reference that? Oh, and then here, this is meant to hold the description of this new to do object. And so how we do this is we have a ID of description and a name of description, and then we need to reference th::field equals star open squiggly description. And everything else looks correct. And so this is this object, new to do. This needs to be created in the controller and passed to this view for us to reference here. So back in our controller method, remember how in our page controller, how we had this model in view. So now when we're back in here, all we have to do is model and view dot add object, and then we called it new to do. So that's the string name of it. And then we're just going to say new to do. We'll create a new and empty to do each time we load the page, which will then be tied to that form for submitting the creation of a new to do. And so we've got an action here of /todos/new. So that means we need a controller to handle this action request, this post action request. So back up in our controllers folder, let's create a new file and we'll call it to-do form controller.java. And it's a class. And I kind of called it this way because this is the only controller that handles a request from the front end via Thymeleaf. So we're creating a few different controllers here that'll hopefully demonstrate some of the different ways that you can make use of in your own Spring Boot application to submit data or work with data in general. So this will be using @controller and @required args constructor annotations. Okay, we're going to be making use of the to-do service again. So we'll use the final keyword and reference our to-do service. So what this does, maybe I didn't mention it earlier, when you declare something as final and then pulling in an existing object that's in your application, so in this case, a to-do service object, when you use the required args constructor annotation for this object, then what Lombok will do is it will attempt to map the variables that you've declared as final via this required args constructor to use dependency injection to get them into your be able to access them within this controller. It's a way of making use of Spring Boot's dependency injection support. Okay, so we need to listen for a post call. Remember from the form, it's a post mapping, and we called it /todos/new. So you can call it whatever you want. Just make sure that this post mapping name here matches what's in that form. So we're going to return a string, and we'll call the method create to do, and we'll make use of @valid to do new to do. So it will try and read in and create a to do object from the to do object that's being passed into the Spring Boot server from the front end. So by default, we've got a status. We're going to set the status to be status type backlog. And then we're going to save with a to-do service.save. And then finally, we're going to return a redirect back to itself. So basically, you just reload the page. Okay, so this all looks good. So when we submit the form, let's go back to the form. So when we submit the form to our /todos/new listener on the controller, we're using the new to-do object and filling in the description field from this input field in the HTML. And so once we submit that form object back to this controller, the to-do form controller, then Spring Boot will attempt to map the object in the request stream to a to-do object. And then before we save it, we want to set the status of this new to-do to be backlog, and then finally persist it in the database through the service call, which then in turn calls the repository interface. And finally, we redirect to the default root URL of our application. So let's go back and test it. So by now, things should have reloaded. Let's go to localhost 8080. Okay, and so let's add a new description. We'll call it new item. Okay, so it looks like the call is successful, but of course we don't see it because we're not displaying anything from our lists. If we quickly go and refresh the database that we got open, the database connection, we've got our new item created in the backlog, created just a few seconds ago. So that all looks good. So now what we want to do is actually read what's in the database and display it on that index page. So back to our template, we've got our 3 different rows which represent the 3 different lanes, so backlog, doing, and done. And so what I'm doing here is I've got a unordered list, and then we're going to go through a list of objects and then make use of Thymeleaf to print them all out as individual list items. Okay, so let's go through this here. So we've got a list item, we've got a class of border info. I remember how I've given it a blue border for the items that are in the backlog. And then the th each is how we go through a list of the objects that are available to us in the view. So we've got a set defined in backlog, which we haven't created yet. So don't worry if you don't recognize what this is. We'll go back and create it in 1 second. So just pretend that we've got a list here. We've got an array of to-do items in a object called backlog. Then with the help of th:\each, we're referencing each of them as just a single to-do. That's the variable name that we're giving it. And all we're doing is creating a new list item with text of todo.id. And then finally, using th:\text with a value of to-do.description. So we're looping through each to-do item within this backlog array and then displaying an ID and description of it. So this won't work right now, of course, because we haven't defined what this backlog array is. And so back in the page controller, this is where we need to add it. So after we add our new to-do object here, we can go and declare model and view.add object, and we called it backlog. And then what we want to do is use the service, to-do service, get all by status. So we're going to filter all of them, filter them down by a status of status type backlog. Now you might be scratching your head because we haven't yet created this method in the service yet. So let's go ahead and do this right now. So you'll see the angry red squiggly because it doesn't exist. So we've called this method get all by status. So let's go back into our service, to-do service. And I put it underneath the get all. Let's create one called get by status. So we're going to create a public method. We'll return a list of to-do and get all by status. And then we'll be accepting a parameter of status type. And then what we want to do is return our to-do repository, and there'll be a special method called find by status. And then you might be scratching your head a little. Well, let's just resolve this. Okay, so you might be scratching your head because we've also haven't declared this yet. So in our to-do repository interface, what we can do is create methods to help us create a way of better working with our data. So let's declare a method here, returning a list of to-do and find by status. So notice how when you start a find by, the interface exposes a whole bunch of different fields that it'll let you set up according to the different object that you're working with, which in this case is our to-do. So we can use this to create specialized methods to find by our created at timestamp or our description, or find it by ID, which is there by default, or a status or the updated at field. So here we're going to use find by status. That's how we're going to declare it, accepting our status type enum. So all that looks good. We're going to go back to here, and all this now resolves properly. So now when we call get all by status, then we will return just a filtered list of to-do items with the given status. Back to that controller. Okay, so we've defined it in the backlog. We're setting it as a backlog object in the model and view object, which is then referenced by the view. So we need to do similar things for the doing and the done lanes. So let's just cut and paste this 2 more times, and instead of backlog, the next one will be called doing, and the last one will be called done. And then the get all status for the second one will be status type.doing. And then finally, status type.done. And then so back in the view, remember how we declared this li snippet here. We're going to just cut and paste it for the other two columns. But instead of backlog, we're going to be using the doing object. And then instead of the backlog declaration here, we're going to be using the done object. And instead of the border info, we're going to use success. And we're going to use warning for the ones that are in progress. Okay, so everything looks good there. Let's go ahead and refresh the application. Okay, so we've got our new display up and running. We've got our 4 different items that are in the database already. We've got the 2 that are in the backlog status. We've got the 1 in the doing status and the done item here with of course, the done status. So let's add another new one. So let's go watch movie. Okay, and now it will watch. We've now added a new object, and it's in the watch movie. It's got a watch movie declaration and in the backlog lane. So I think we're almost done. The one thing we haven't yet done is added a handler. So what I set up to do in the demo is that the only way to move these to-dos between the different lanes is to click on them. So right now, of course, they do nothing because we aren't set up to handle the click. We haven't set up the click handler on any of these HTML elements. So let's go back into our Thymeleaf and let's set that up right now. What we'll need to set up in Thymeleaf is a th::onClick handler. And we need to pass in a string that it will then use, Thymeleaf will work with to set up the click binding on this element. So we are going to be calling some JavaScript, and then I called the method onHandleClick, onHandleListItemClick, kind of a long name, and then I am inserting the to-do item ID. Okay, and then finally closing this thing off. So when we click on each of these list items, it will then be tied to an onClick handler, which will call the JavaScript function onHandleListItemClick, and it will pass in the to-do ID. So while that looks good, I am going to add the same click handler to the doing list iterator function. And then we can also put it on the done. So we've called this method onHandleListItemClick. And so back in our, remember we set up our app.js file. Let's go ahead and go back into this now. And let's add some JavaScript to listen for that. Okay, so let's create a onHandleListItemClick handler. It will be asynchronous, and it will be given a parameter ID. So we'll pass in the ID of the to-do item that we want to modify. So let's create just a basic console log to make sure we got in here. So click, and then we'll display the ID, and then we'll set up some options. So our method here will be put, because we're updating a to-do record. Our headers we will declare as content type application JSON, and then we're not sending in any data, so I'll just leave this empty. And then we'll use the fetch method, which is available to basically all browsers right now. So const response equals await fetch, and then we'll be going to /todos $ID. So we're going to reference the ID of the to-do we want to modify, and then we'll pass it the given options of options. And then we'll translate that response into JSON. And then finally, we will reload the page. Not perfect, but whatever. And let's display this first. So console log data. So before we reload the page, let's display the result from the server. Let's just verify that that's coming back correctly. So you can see that we're calling this /todos/ID with this given information of the to-do ID that we want to update, but we haven't yet set this up in the controller or in a controller. So back in our controllers, let's create another new controller and we'll call it to-do controller. And this will be a class, but we will make use of the REST controller annotation because we're referencing it from a actual web service call, like a JavaScript call. We're not going through Thymeleaf or anything like that. And then so we're declaring we're using dependency injection to get the handle to our to-do service again. Okay, so what we're doing here is we are declaring a put mapping. So we're listening for /todos and then the ID of the to-do item that we want to modify. We're listening for a put call for that. Okay, and then so we're saying we're listening for this ID and we're passing it in as a long with the help of the path variable annotation. So then Spring Boot will take that ID that's in the path and then it will translate it as a long that we can make use of in this controller. So we're making use of the to-do service getById function, which we haven't yet defined. So we're going to do that shortly. So we're going to be able to get by a single ID. So get a single to-do given an ID of it. And then with that to-do that we get from the database, we're going to check the status. And so if the status is of status type backlog, then we're going to change the status to be doing. And if the current status is doing, then we're going to change the status to done. And that's all we really need to worry about. So let's go ahead and add this method to our service. So getById. So let's go back into to-do service and let's just add it right in here. So I've called it getById. So we're passing in along, the ID is along, and we're searching for it in the repository interface with the help of findById, which returns what's called an optional, which essentially means that because you don't know if the record is going to be there or not. So it's a wrapper around what could be coming back from the database. So it might be nothing or it might be our to-do item. So if it's our to-do item, then go ahead and return it from this function. Otherwise, throw an exception. So we return back to our controller. Everything now looks good. Let's go back and refresh our page. And let's open up our JavaScript console. Okay, let's keep this up here just so it's legible. All right, so we've got our jQuery ready, text coming out again. Let's update. So we'll click on, let's say, backlog. Okay, and we've got we've got the ID of 1, and then we've got some code coming back. I think it worked. Oh, of course, JSON function. We've got to call the JSON function. That's what we missed. Okay, so let that refresh. All right. So now if we click on let's click on another one. Let's click on this new item. We now see in the console, the call had gone out to our server to update the ID of that given to do. And then we're getting it back. So our description hasn't changed. It's still a new item, but now it's in the doing column. So if we refresh the page, this item is now in the doing column. So let's go back to our application or our app.js and let's just throw in a window.location.reload. So that's just kind of a neat hack to get the page to reload when we update the data. That way the representation of where our to-dos are in the proper columns. And then let's add some CSS just to make things look a little better. So our to-do list, unsigned list, we're going to not use any, or we're going to use a square, sorry, instead of a default dot. And actually, we don't need this border. And then for each to-do list item, we're just going to have a padding of 5 pixels. And then I'm changing the cursor pointer to be a pointer, the cursor icon to be a pointer. Let's go back and refresh. Okay, you can see we've got a padding, and our mouse now turns to a hand when we get on top of each list item, which is cool. And let's move this new item from the doing to done. So let's just click on it, and it should show up here in done, which it does because it refreshed. I think that's everything. Well, that's it for this video. I hope you really enjoyed this tutorial. It was a bit of a long one again. So again, make use of the timestamps to go through the different chapters of all the different topics we went through and covered. Hopefully I've explained everything properly and to your satisfaction. Be sure to leave a comment down below on anything I may have missed, or maybe you need some clarification on something. This is meant to be sort of a sequel, quote unquote sequel, to an existing to-do application that I built on this channel using Spring Boot 2.7. And this is kind of an enhanced, updated version, which makes use of Docker and a lot of the features that have been added to Spring Boot 3. So I really hope you enjoyed this video. Please give it a like. Subscribe to the channel if you want notifications on other videos. Be sure to check the description down below for the link to the GitHub. And again, this will be available on Gumroad eventually, and so the description will be in the link down below, as well as showing up on the screen here in the video. Hope you have a good New Year's wherever you are in the world, and you've celebrated it with your family and friends, and I'll see you in the next video. Peace, everybody.